Hey guys, welcome back to another episode of Science with Mr. Dorm. In this episode, we're going to be talking about weathering and erosion. Now, I love nature and I also love hiking. Hiking is one of my favorite things to do. I did a lot of hiking when I was in Korea a few years ago, and I did even more hiking when I went to Japan a few years after that. It's on the internet. Now, unfortunately, due to the lockdown in Sydney at the moment, it's been a while since I've last been outside. Now, one of the things that I found really amazing, wherever I hiked, was just how rocks and cliffs looked. You look at the side of the rocks and cliffs, you can see cracks in them. You can see that a chunk of a rock has fallen next to a cliff, and you can tell that it was part of the cliff right next to it or around there because the sides of the rock and the patterns match. Right, and I've never wondered why. I just thought it was really cool. Now, this topic of weathering and erosion, I actually didn't learn when I was in school. The first time I learned about this was when I was training to be a teacher, and everything started making sense to me, and it was just so cool. So weathering refers to the breaking down or the degradation of rocks and minerals, not the weather or the weather forecast. Now, weathering occurs naturally and it's all around you. When you go hiking and you see a big rock, chances are it was probably part of a bigger rock or a bigger cliff that had been broken off as a result of weathering. Now, things that promote or cause weathering are what we call agents of weathering. And we often divide weathering into two processes. It's either physical or chemical weathering. We also have biological weathering, but we often break that down into either physical or chemical weathering as well. Now, we're going to start off with physical weathering and go through a few examples. Now, the first example of physical weathering is frost wedging. Now, frost wedging relates to water expanding and contracting when it falls into the crack of a rock and eventually cracking the rock. Now, water is one of those really weird chemicals. Normally, when you heat something up, it expands, and when you cool it down, it contracts. However, water, when you freeze it, it expands, which is why when you're filling up an ice tray, you need to fill it up about 50 to 75%. Otherwise, it's going to overfill when it expands. Now, with this in mind, water is a really key agent to physical weathering. And as we discussed, frost wedging is a process by which water seeps into the cracks of a rock. And upon freezing and expanding, it widens the crack in the rock. And you can imagine if this keeps happening over and over again, eventually the rock is going to split and break completely. Now, thermal expansion is another example of an agent of physical weathering, and it's like exfoliation but for rocks. Now, this type of physical weathering usually affects larger rocks like granite or basalt. And this type of physical weathering usually occurs in places with large variations in temperature throughout the day and night. For example, in the deserts where it's really hot during the day, causing the rocks to expand and then contract as a result of rapid cooling at night. Now, this expansion-contraction causes separation of thin rock slabs from the surface of larger rocks. It's like your skin cells peeling off. Now, tree root is the last example of physical weathering that we'll discuss in this video. Now, plants and animals also contribute to physical and chemical weathering. Now, sometimes a seed of a tree or a plant may sprout in the soil that has fallen or collected in a crack of a rock. And as the plant grows, so do the roots. And when the roots become thicker, they widen the crack, eventually breaking the rock into pieces. And over time, trees can even break large rocks. So in summary, physical weathering usually changes the physical appearance of a rock. For example, its shape, its size, and what it looks like. Chemical weathering, on the other hand, changes the chemical composition of the rock. It changes the chemical makeup of the rock and is usually caused by water and other chemicals reacting with the rock. Similar to physical weathering, anything that causes or promotes chemical weathering is what we call an agent of chemical weathering. So in this lesson, to keep it simple, we're only going to be talking about chemical weathering by carbon dioxide and water. Now, carbon dioxide from air or soil sometimes combines and mixes with water through a process called carbonation. This process produces a weak acid called carbonic acid, and this can dissolve rocks. Carbonic acid is also produced in your body, which is why you really want to breathe properly when you're doing things like exercise that produce excess CO2. This carbonic acid is especially effective at dissolving rocks like limestone. So when carbonic acid seeps through limestone underground, it can open up huge cracks or hollow out networks of caves. That's so cool. Sometimes when this happens, the ground will actually give way because the rock underneath has been dissolved or eaten away by the carbonic acid and creating a sinkhole. Now, anytime iron reacts with oxygen, a reaction called oxidation occurs, producing rust. Minerals that are rich in oxygen break down as the iron oxidizes and forms new compounds. Iron oxide produces a red color in soils, and as the rust expands, it weakens the rock, helping it to break apart. So weathering is the process of breaking down rocks, whether it be physical or chemical weathering. After the rocks have been broken down, it needs to go somewhere. It doesn't just stay there. They often get carried away to the Earth's surface or across the Earth's surface. And this process is what we call erosion. Now, weathering and erosion are complementary. We don't get one without the other. There is no erosion unless things have been broken down as a result of weathering. So weathering breaks down the rocks, and erosion is the process of the rocks being carried away across the Earth's surface. Anything that causes erosion, again, is what we call an agent of erosion. An example of an agent of erosion is water. Now, water is one of the most important agents of erosion. So strong river currents carry gravel and sand from mountains up high to the lakes down below. Think about mudslides and heavy rain, pushing all the rocks down and sometimes causing damage and congestion on the roads. Now, wind is another big agent of erosion. Wind carries small and light particles of sediment. And the Australian outback experiences dry desert winds that carry sand all the way to the ocean. Also, think about going to the beach on a really windy day. The wind picks up the sand and it blows it and it hits your leg really hard and it really hurts. Now, gravity is also a powerful agent of erosion. It's the force that literally keeps us grounded and also erodes large amounts of rocks and sediments, sometimes leading to landslides. It's a really strong agent of erosion, so much that it can even erode large boulders. Now, there are many factors that increase or decrease the rate of erosion. The process tends to happen more quickly in high mountainous places because there's more exposure to wind and there's larger gravitational potential energy in higher areas. Now, the Grand Canyon in America was also created as a result of water eroding away the rocks and the land. The rocks that make up mountains are gradually eroded away. Some mountain ranges, like the Southern Alps in New Zealand, are eroded away as quickly as they are formed. While on the other hand, flat regions such as plains and deserts don't experience nearly as much erosion. After the process of weathering, where rocks and bits of land are broken down, the sediments have to go somewhere. They're carried away by erosion and the sediments usually settle somewhere, right? And when they settle, when they get carried away and they settle in a certain area, that process is what we call deposition. And that's it for this lesson. So this lesson we've learned about weathering and erosion. For weathering, we learned about physical and chemical weathering, and in erosion, we learned about agents of erosion, where it occurs, where it's more likely to be more severe than it is not. Thanks for watching, and I'll see you in the next one.